Alright, so for our last example, we have a problem with a seesaw. So here I'm going to draw my picture. The pivot is right in the middle. And it says we have a 20-kilogram child sitting on one end, 1.5 meters from the pivot. Now remember, the total pivot is 3 meters. So that's the radius for the first child, and they're going to apply a force on the end equal to the child's weight, or force of gravity. Now the sibling is going to sit somewhere else on the seesaw, and the sibling has a mass of 35 kilograms and will apply a force equal to their weight. But they will have to sit at a different location to balance the seesaw, and that location is what we're trying to find. Since the seesaw is going to be balanced, that means my net torque, or the sum of all of my torques, must equal 0 Newton meters. So we're going to start by figuring out the direction of my torque. This child will cause a rotation in this direction, and that is clockwise, so that's going to be a negative torque. This child will cause a direction in, or cause rotation in that direction, so that is a positive torque. So when I go to add those together, I'm adding a positive and a negative, and that will have to equal 0. So it's good that these will cause opposite rotations. This force of gravity is going to be equal to our mass times 9.8, and this force of gravity will equal the other child's mass times 9.8. So now we're going to just write our equation. We're going to add all of our torques together. Remember, torque is going to be the perpendicular force. In this case, the weight is already perpendicular to our seesaw. So I'm going to add them together. 20 times 9.8, there's my perpendicular force, times a radius of 1.5, that's positive. Now this next torque is negative, so I'm going to subtract it, minus, or add a negative, which is the same thing, minus 35 times 9.8 times some unknown radius, and that radius is what I'm trying to solve for. That has to equal 0 Newton meters. Now I did this to show you that because there is 9.8 in every term, I could divide every term by 9.8 and not need it anymore. So really, when you have a seesaw problem, that 9.8 isn't very useful. We can just use the mass. So our equation becomes 20 times 1.5, and again, that's only because it's in every term, minus 35 times r equals 0. So now we just follow the algebra steps to solve for r. 20 times 1.5 is 30, minus 35r equals 0. I'm going to take the 35r to the other side. So 30 equals 35r. To get r by itself, I'm going to divide both sides by 35. And so r equals 0.86 meters, or 86 centimeters. Now, does that make sense for our problem? Well, 86 centimeters is going to be somewhere closer to the center, and since this person has a larger mass, they are going to have to sit closer to the center in order to balance out the person with the lower mass. And that's how you're going to use the net torque equation.